towards. So word problems, the important thing is that you set up a variable. If you read the problems, see what they're asking, you set up a variable, and then you set up an equation, and then you solve the equation, and then you check, you answer the original problem. Okay? So in this one, it says a candy shop sells gummy worms for $2.50 per pound and sour balls for $1.50 per pound. I bought 8 pounds of candy for a total cost of $17. How many types of each type of candy did I buy? Okay? So I'm going to say you have to set up your variables first. So let G equal the pounds of gummy worms. Okay? Pounds of gummies, okay? Because that's what you're trying to find. And what's the other thing I'm looking for? Sour balls, okay? Those used to be my favorite when I was a kid. That's pounds of SBs, okay? Okay, SBs. So who could give me one equation? One equation. I bought 8 pounds. Go ahead, Quinn.
G plus S equals 8.
Right. G plus S equals 8. The second equation becomes a little more trickier. Okay? Can anyone give me an equation for this second one? Let Quinn try. Go ahead.
2.5G plus
Oh, you're the man.
S
Yep. 2.5G, you've done this before, plus 1.5S equals 17. Do you guys understand where that came from? Because altogether I spent $17, and each pound of gummy worms costs $2.50, and each pound of sour balls costs $1.50. Yeah, $1.50, and so I said it like that. Now to solve this, what do you think? Substitution or elimination? What should I do? Elimination? If I were doing it by elimination, how would I do it? Times everything? Yeah, that'd be kind of messy. Okay. What do you think, Jacob? Negative the top one by negative 1? By negative 1? Yeah, it's not going to help you, I don't think. Yes. Yeah, I think I mean, you could do it by elimination. Would you come down over there? Young man, keep your shirt on in class. Right. So if I solve this for G or S, let's just solve it for S, right? I get S equals 8 minus G. You guys understand that? Okay, that's a G. It looks like a 6, okay? I subtracted G from both sides, or I could subtract S from both sides. Doesn't really matter. Now I'm going to take this. I'm going to change colors. I'm going to take this and plug it in over here, right? Okay? And so I get 2.5G plus 1.5 times 8 minus G equals 17. Do you guys understand what I did? Okay. And now I have an equation that just has G's in it. So I have 2.5G. I know my G's look like 6s. I don't know how to make them look better. Plus, what's 1.5 times 8? 12. That's not too bad. Okay. That's 12. Minus 1.5G. And let's get rid of this mess over here. Equals 17. And then I'm going to combine my like terms. That's a G. That's a G. Looks like a 6. So I'm going to subtract 12 from both sides. Subtract 12. And I'm going to add together my 1.5G and 2.5G. What's 1.5G and 2.5G? 4G. Hey, I have that on my phone. 4G, that goes away, equals 5. So G equals?
Yeah, G.
Oh, I knew that. You can't fool me. I was just checking to see if you guys were paying attention, okay? One of the g's is negative, so I subtract, and I get g equals 5. Look, I'm almost done, aren't I? And now I know that s equals 8 minus g. So if s equals 8 minus g, how many sour balls, how many pounds of sour balls did I buy? 3, because g is 5. Plug in 5 in there, and I get s equals 3. So then you have to answer the question. I bought 5 pounds of gummies, 5 pounds of gummies, and 3 pounds of ESPYs. Do you guys know what sour balls are? They're those little things in little wrappers, and you pull them on the ends. You know what those are. Right? I used to have them.
Are they like yellow balls?
They're all different colors. It's like, they're like lifesavers, kind of, except round. Some of them are sour. No, they're kind of more like lifesavers. What? No, more. They're more the consistency of lifesavers. You know.
Chew?
No,
Like chew?
hard. Okay. Anyway, that's how you do that type of problem. Let's move on to the next one. All right, my grandma used to give them to me when I was a kid. If I was a good kid. If I was a bad kid, she didn't give me any. You want to create 20? So these ones, these mixture problems, can get kind of scary, okay? So this is a mixture problem. The next one isn't too bad, but mixture problem. You want to create 20 pounds of a, you want to create 20 pounds of a mixture of M&Ms for your birthday party. You want to mix custom printed M&Ms that cost 60 cents per ounce with regular M&Ms that cost 25 cents per ounce. You need a mixture to cost 32 cents per ounce to fit into your budget. How many ounces of each type of M&Ms do you need? Okay? So this is kind of how they tell you to set it up in the book. They tell you to make a table, kind of like this. Okay? I'm looking at my cheat notes over here. Okay? And over here. And then one more column over here like this. And with a mixture problem, you have your custom M&Ms. And you have your regular M&Ms. And then you have your mixture over here. Because it's nice to have a nice organized table to number of ounces. Whoops, OZs. Okay? And then we have price per ounce. And then we have value of mixture. Value. Okay? Or price or something like that. So, you want to create 20 pounds mixture of M&Ms for your birthday party. You want to mix, so altogether, you want to mix custom M&Ms that cost 60 cents per ounce with regular M&Ms cost 25 cents per ounce. You need a mixture that costs 32 cents per ounce into your budget. Number of ounces. We don't know this yet, right? So I'm going to call this custom. I'm going to call this regular. I'm going to call this what? 20. This is number of ounces. Do you understand where that came from? What? Oh, 20 pounds times 16 ounces per pound gives you 320 ounces. Okay? 320 ounces. I knew that. Again, I'm always just checking to see if you guys are paying careful attention. 320 ounces. Okay? Price per ounce. Well, it tells you that, right? The custom ones cost 60 cents. So we're going to multiply that by 0.60. You could just call it 0.6. No, we'll call it 0.60. And regular only costs 25 cents a pound. And you need the mixture to cost 32 cents per pound. Okay? So that's 0.32. Now, all you do down here is multiply each one of these. That's 60 cents times the number of ounces, 25 cents times the number of regular ounces equals 32 cents times the number of this ounces. You get that? So when you set these problems up, you get 0.6 C, 0.25 R, 0.32 times 320. Yes? So it's really important that I think that you set up a table like this to help you with this type of problem. Okay? So now you have two equations. You have one equation here, and you have another equation here. Okay? And so let's write down our system of equations. C plus R equals 320. The next equation looks like 0.60C plus 0.25 R equals this times this. You just do it on a calculator. And if you do it on a calculator, you get 102.4. Right? What method do you think you should do? You could use either method. What method do you want to use to solve this? Should we solve it by elimination? But we could do substitution. Let's do elimination just for kicks. So much harder. It's not that hard. What could I multiply this equation by to turn this into a negative R?
No, just multiply the top one by negative 25.
How about if I multiply this one by negative 4? Right? Because that'll turn this into a negative 1, and then when I add them, things will disappear. Get it? See what I did? I don't think that's too bad. So I'm going to multiply this equation. That's the way I would do it. I hate substitution. Well, I don't hate it, but I just think elimination could be easier. So when I do this, I get C plus R. You could do it by either way. I mean, you could do it by substitution, but I multiply this, I get negative 2.4C, right? Minus R equals, because 4 times 0.25 makes negative 1, right? So that makes negative R over here, negative 1R, which is the same as negative R. And 4 times this gives you, negative 409.2. Did I do that right? 409.6. Thank you. Okay? And then I'm going to add them together. Okay? I'm going to end up with a negative number, but that's okay because I'm going to have a negative number over here. So this plus this gives you negative 1.4. Is that right? 1 plus negative 2.4 gives you negative 1.4 C. And negative this plus negative this gives you what? 89.6? Negative 89.6? Is that right? Yes? 89.6. And then I'm going to divide both sides by negative 1.4. Negative numbers, got to be good with those. Okay? Negative 1.4. And when I do that, hopefully, does it come out even? Let's find a calculator. What do you get?
64.
Exactly?
Yeah.
Ah, nice. Okay. We won't go to our calculator. So when I do that, I get C equals 64. Right? And then I could just take that and plug it back in here. Okay? And I get R equals 64 from 320. What's 320 minus 64? 320 minus 64? 256. 256. That's what I said. 256. 200, not a C, 256. So those are your two answers. You need 64 ounces of custom and 256 of regular. So this is like a real life problem, you know? Isn't it? Kind of. If you're mixing up M&Ms, or if you work at the bakery, or if you're trying to mix your oil with your, I had to do this the other day, because I bought my new leaf blower, and it's a two-cycle engine, two-cycle engine. I go, wee, 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 the ones that really annoy your neighbors.
Like the one from SpongeBob?
What?
Like the one from SpongeBob?
I don't know. I haven't seen SpongeBob. I've seen it a long time ago. But you have to mix when you use that kind of engine. It's called the two-stroke engine. You have to put oil into the gas, and you have to have a certain percentage mixture of gas and oil. And if you don't always have the right amount, you have to figure out how much oil do I need to put in the gas. And so it is a real issue. Okay? Or if you have a little some motorcycles and stuff, or chainsaws, chainsaws. Okay. Yeah, but they're really good if you don't like your neighbors. You just do that at like 7 in the morning on a Sunday. I really like it. Okay. But I like my neighbors. Okay, last one we're going to look at. And again, really with these, I didn't do it, but you should be checking your answers by plugging them back into the original equation. This is very similar problem. Suppose you work in a lab. You need 30 liters of a solution that is 40% acid, but you only have a solution that is 25% acid and another one that is 50% acid. How many liters of each type should you make? Okay? Well, this reminds me of my family, because you have a lot of liters, You don't get it? It actually reminds me of my Aunt Millie, because do you know my Aunt Millie? Millie Leader? She was only about this big, Okay. Millie Leader. That was the worst joke of the year? Number of liters, percent of acid. I think you guys could do this one, because this is really the same thing. Amount of acid, okay? So this is a classic solution problem. First solution, second solution, and here's your mixture. It's almost exactly the same as that last one, okay? Mixture. So we're going to call this, we'll just call number of liters of the first one. So let's read the question again. Suppose you work in a lab, you need 30 liters of solution that is 40% acid, but you only have a solution that is 25% and one's at 50%. So you need to mix them together to make 40%, okay? And you can't just take these two and average them or something like that, so it becomes kind of tricky, okay? So how many liters do you need altogether? 30 liters, right? And I'm just going to call the first one X and the second one Y, okay? Percent acid, well, you have one mixture that's 25%. And one mixture that's 50%. And then this is just going to be, and that you want a solution that's 0.40% or 40%, like that. And then you just have 0.25x, 0.5y, 0.5y equals 0.40 times 30. And that's all you do. Here's your two equations. Equation 1, equation 2. And then could you solve it if you had to? Should we keep going?
No.
No? Who said no? Claire said no?
Yeah.
Kaylee said no. Oh.
That was enough.
Fidel. I mean, Andy. Can you put your phone away?
Sure.
Okay. All right. So here's my two equations. Let's just do one where we can solve by substitution, because it might work out a little bit better. So 0.25x plus 0.50y equals, who can tell me what 0.4 times 30 is? Comes out even, I think, 12, okay? So now I'm going to take this equation and turn it into y equals what? What does y equal? 30 minus x, okay? And I'm going to take that 30 minus x, and I'm going to sub it in to here, okay, for y. Okay? So now I'm going to do substitution. So I got 0.25x plus 0.50, and you must put this in parentheses or you're going to make a mistake, equals 12. Okay? And then what I like to do, does anyone know what I like to do? I like to clear the decimals out. How can I get rid of those decimals? What can I multiply everything by to get rid of all the decimals? 4? Oh, I could multiply by 4. What?
Move it over to this one.
Yeah, you can move it. Well, then you'd have to move this over. Let's not do that. Let's just forget it. I'll get you confused, okay? So I'm just going to multiply out 0.25x. 0.5 times 30, I believe, gives you 15. Minus 0.5x, 50x, equals 12. Again, I'm going to combine my like terms. Uh-oh. I'm going to end up with negative. That's okay. So I get 0.25 minus 0.5 gives me negative 0.25x plus 15 equals 12. I'm going to subtract 15 from both sides. Subtract 15, subtract 15. I get negative 0.25x equals negative 3. And then I divide both sides by negative 0.25, which is the same, by the way, as multiplying by something. Anyone know what that's the same as multiplying by? 4. It is the same as multiplying by 4. So when I multiply both sides by that, I get x equals 12. Okay? Or if I just use my calculator and divide it by that, I get 12. And since I know that y equals 30 minus x, what's y equal to? 18. And then I have my two amounts of my mixture. Did I go too fast? Okay. No? So going back up here, let's just kind of look at it real quick to make sure everything makes sense. So this is 12. Let's turn it into different letters. If this was 12 and this is 18, yes, they add up to 30. If this was 12 and this was 18, let's see. What's 1/4 of 12? 0.25 times 12. What's that? What's 1/4 of 12? 3. What's half of 18? 9. And this times this makes 12. So does 3 plus 9 make 12? So it checks up here and it checked up here. So then you answer the question. I need 12 ounces of the first solution and 18 ounces of the second solution. Okay? I didn't do this when I was cutting or blowing the leaves the other day. I just guessed. That's why my leaf blower, I have to buy a new one every year because I don't put in the right amount of oil and it blows up on me. So, but I should. Next time I'm going to do that. Maybe. Yes, Ian, did you have a question? They were just right. Okay, so I'm going to pause here. Okay, pause. Continue here with this lesson. So you should be on this problem. So with these ones, suppose you have $15,000 invested, part of it at 3% and the rest at 4.5%. This is the classic kind of interest rate problem that you will see. In 1 year, the investors yielded $573. How much was invested at each rate? So what you do is you say something like, let X equal amount invested at 3%. And then you say let Y equal amount the amount invested, what's that should be, at 4.5%. And then you make two equations. And you know that x plus y equals something. Who knows what x plus y is equal to? What's x plus y equal to? How much altogether? Jessica? 15,000 altogether, right? X plus y equals, because this person invested they took their $15,000 and they put in so much at 3% and so much at 4.5%. By the way, do you know why you wouldn't invest all your money at one interest rate and other interest rate? Anyone know? No, this is what? Well, usually the ones who have higher interest rates, they could be like more risky or something like that, or they'll have some downside to it. Okay, so in any case, $15,000 to different interest rates. Then you write another equation, 0.03 times x plus 0.045 times, is that right? 0.03, that's right, y equals $573. Hey, let's go back to your proper seats, please. Okay, so here's my table. We're still recording. So now I have two equations. I have 50t equals d, and then my other equation is 70 times t minus 2 is also equal to d. So if both of these are equal to d, do you know what I could do? Substitute. Okay, so what I'm going to do, I'm going to substitute this into here for d. See that? Easy? So now I get 50t equals 70 times t minus 2. And then I just finish out the problem. 50t, I distribute 70t minus 140. I'm going to bring my 70t onto the left side. 70t minus 70, that's a 70. Minus 70t, and I get negative 20t equals negative 140. So what's t equal to? What's t equal to? 7, right? So t equals 7. They want to know the distance. So how do I figure out the distance? Because that's a question. How far from Denver will they meet? If t equals 7, and the car is going 50 miles an hour, how far did he go? 350, right? Because I know that d is 50 times t, okay, or 70 times t minus 2, right? So if I multiply 70 by 5, or 50 times 7, I'll get the answer, and d is equal to 50 times 7, which is 350 miles. Did you follow that problem? Maybe you did, maybe you didn't. You can look back at your notes and see. We got one more to look at, okay? Sorry, that's why I broke it up, because I wanted you guys to have a little intermission, you know? Okay, last type of problem, I think it's kind of easier than this one, but it's also a rate times time, and this is another type of problem that you'll see again and again. It's also a rate times time problem. So let's just set up a table like we did for the last thing. Here we go. So if you see rate times time equals distance problem, I'd set it up like this. Rate times time equals distance. Okay? And we have a motorboat. Chad. Is Chad in here? We don't have a Chad in here, do we? We have a Chad. Chase. We have a Tate. We don't have a Chad. Okay. Chad's motorboat took 3 hours to take a trip downstream with a 6-mile-an-hour current. The return trip against the same current took 5 hours. Find the speed of the boat in still water. Okay? So what you want to do is, like, here's the, so you have, I would put over here the trip, okay? And this is like downstream, 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 and here's the upstream's trip, upstream, upstream. And I'm going to let R, well, let's just do it this. Let S equals speed in still water. Still water. And water. How do you spell water? 1D, I need it. Okay. So downstream, and we already know what the current is. So the idea is that if you're going with the current, you're going this much faster. If you're going against the current, right? If you're trying to go this way and the current is pushing you that way, straight in your face, you're going that much slower. Okay? So its rate with the current is R plus 6. You get that? What's his rate against the current? R minus 6. Okay? And this, you'll see it with like airplanes, you'll see it with like boats, you'll see it with like, you ever go to DIA and you try to walk up, you try to go backwards on the, you know, those long things, right? If you're walking on the, you know, you're walking on the walkways, you can go like super fast, you know, and you'll be like, hey, you know, like that, you know, and then then I like to go. My kids like to go when they're going the wrong direction, see if they could, you know, you've done that, right? So anyway, it's kind of that same idea. So R plus 6, the time takes, with the current, it takes 3 hours. And D is the distance. You don't know what the distance is, but we're just going to call that D, okay? And R minus 6, how long does it take him with the it takes him 5 hours, which would make sense, right, because he's going slower, and that's equal to the distance, okay? So in this case, you have one equation that's R plus 6 times 3, I'm going to put the 3, equals D, and 5 times R minus 6 is equal to the same distance. Yes, ma'am?
Except you wrote S for variable.
Oh. Okay, we'll change it. Let R equal the speed in still water. Thanks. Okay? So now I have two equations, two unknowns. I can just take this whole thing and substitute it into here. Okay? So now I have 5 times R minus 6 equals 3 times R plus 6. And this is a very simple equation to solve. 5R minus what? 30 equals 3R plus 18. I subtract R from both sides, right? Minus 2R minus 2R. I get 3R minus 30 equals 18. Oh, minus 3R, sorry. 2R minus 30 equals 18. Add 30. See, it's good you guys are keeping me awake, okay? I only had 6 cups of coffee this morning, okay? And so I get 2R equals 48. What's R? 24. R equals 24. So in still water, the boat goes 24 miles an hour. See if it makes sense. Downstream, he's going 30 times 3. How far did he go downstream? What's 30 times 3? 90, right? Upstream, he's going 24 minus 6, which is 18 times 5 hours, so it's 18 times 5. 90, and it checks out. You see? You want to check your answers? Okay? So his rate is 24 miles per hour If the boat were just going in still water, he'd be going 24 miles an hour. Okay? That's the end. Your homework is in your book. Okay? Page, I forgot what page it was. Page 175. Um, 21, 24, 27, 38, 40, and 47. Okay? So that's 6 problems. That's it. There's no Math XL today. Okay? So that's all.